Hello everyone, in this video we are going to solve a complex number problem which is itself a complex problem. In the problem I to the power root I is given. You have to write this number in the form a plus ib because any complex number can be written as a plus ib for ab reals, right? Well, so here you have to express I to the power root I as a plus ib, and then a plus b value is nothing, and that is not the interesting part. The interesting part of the problem is to find the a plus ib form of the complex number, and such problems are really famous. Okay, we know that I to the power I is a real number. Okay, like such problems are famous actually. So in this problem we want to go with I to the power root I, and we want to write it as a plus ib. Okay, of course a and b are real numbers, because if we take a and b to be complex number, then there are many such expressions. Okay, anyway, so by definition, what is I to the power root I? In general, if you have a complex number a which is non-zero and you have z any complex number, then a to the power z is by definition it is exponential z capital log a, and this capital log is actually multi-valued. Therefore a to the power z can actually have many values. Okay, so a to the z can have multiple value. So how to deal with this? We make a convention here that we will work only with the principal values. Okay, what are principal values we will see in the context. Okay, so then if we consider the principal values, then a to the power z becomes exponential z log a, which is small log now, and small log a is the principal value of capital log a. Okay, fine, and we will work with only principal values. Well, then in our problem a is just I and z is square root of I. Okay, so our target is to first find principal value of square root of I, what it is, right? And square root means I to the power half, right? Okay, so for that we need to write I in the polar form r cos theta plus I sin theta. Okay, this is the polar form of I. If this is the polar form of I, then r is the modulus of I, then r must be 1, and theta is the principal amplitude or principal argument of I, which is pi by 2, because the number I is on the y-axis, the angle is pi by 2 with the x-axis, right? So r is 1, nothing is there, and then theta is pi by 2. So this is what is I, right? Then what is I to the power half? Okay, so I to the power half is of course cos pi by 2 plus I sin pi by 2 whole to the power half, right? And then we know by de Moivre's formula it is cos pi by 4 plus I sin by 4, and this is being the this being the principal value, right? Because it can have many other values. Okay, actually if it is square root, then it has two distinct values, others are all one of these. Okay, one is cos pi by 4, another is corresponding to n equal to 1. Okay, which maybe it is 3 pi by 4, right? So here it is the principal value, therefore we will only work with cos pi by 4 plus I sin by 4. Okay, this is root I, this is the value of root I. Then what is I to the power root I? So basically I to the power root I value, which is cos pi by 4 plus I sin pi by 4. Okay, and now a to the power z definition we remember exponential z small log a, because we are working with the principal value. So write the formula here, exponential z, which is this z, right? Cos pi by 4 plus I sin pi by 4, which is here, and then log a is I, so log I, right? Now what is small log of I? That we also must understand. Okay, for any complex number z which is written in polar form r cos theta plus I sin theta, then you can also write r cos theta plus I sin theta as r into exponential I theta, right? Okay, then it is obvious to guess what is log z. Log z is log r plus I theta. This is the principal log of z. Okay, yeah. So then we have I equal to cos pi by 2 plus I sin pi by 2. We have seen this in the previous slide, and therefore what is log I? Log I is log of the r is the modulus, and modulus of I is 1, so this is log 1 plus I into theta, right? Theta is pi by 2, so I pi by 2, but log 1 is actually 0, so therefore what you have is just I pi by 2, and then this I pi by 2 value we will substitute here. So what do we get then? Cos pi by 4 is 1 by root 2, and sin pi by 2 is 1 by root 2. We have written the values, and log I is just I pi by 2. So this is this, okay. And if you just simply calculate, this is I will give you a real number, which is -1, then minus pi by 2 root 2, minus pi by 2 root 2, and 1 by root 2 times I pi by root 2, I pi by 2, which gives I pi by 2 root 2. So exponential of this complex number is the value of I to the power root I. But still, we don't have the form a plus ib, right? For that, we need the definition of exponential function. What is that? So exponential of any complex number x plus iy is actually e power x times cos y plus I sin y. This is the very definition of exponential x plus iy, any complex number x plus iy, right? And then in our case, I to the power root I was exponential of minus pi by 2 root 2 plus I pi by 2 root 2, which is nothing but using this formula, you can write this. So e power x, e to the power x, because x is a real number now, you can use e power x. When we use exp, when this number is actually a complex number. If it is real, you can just write e to the x, right? Here minus pi by 2 root 2 is a real number. So e power x times cos y, okay, this is y pi by 2 root 2 plus I sin pi by 2 root 2, right? Okay, fine. This is just by the definition of exp. And then this is in the form a plus ib, okay, and therefore from there you can clearly write, okay, a plus b to be this. So this whole is a, and e power minus pi by 2 root 2 and sin pi by 2 root 2, this is b. So a plus b is e power minus pi by 2 root 2, this plus this, and that's the final answer. Okay, this was complicated, and it is like only in competitive exams and other exams these questions are asked, because it's not so easy to find out these values. Yeah, and that's all in this video. If you like the content, do press the like button and subscribe our channel to motivate us. I sincerely thank you for watching this video.